Hello students, in this video we'll classify the geodesics on surfaces of Liouville. So we call a surface S a surface of Liouville okay, the same Liouville from complex analysis, surface of Liouville, if its first fundamental form has the form ds squared is equal to f of u plus g of v. So that's your prefactor, and then times the ordinary metric, du squared plus dv squared. So these are the metrics. That's the first fundamental form of a surface of Liouville, right? And so in this case, we have E equals F, right? So in other words, E is equal to G, and F is equal to 0, right? So now let's write down the geodesic equation. So recall the geodesic equations are what? They're d by dt E u dot plus F v dot is equal to 1/2 E u dot squared plus 2F u dot v dot plus g v dot squared. And the second geodesic equation is what? Is d by dt of F u dot plus g v dot is 1/2 EV u dot squared plus 2FV u dot v dot plus, that's a u of course, and then GV v dot squared. Beautiful. Now there's no f's in these equations, so this term is gone and this term is gone, this term is gone and this term is gone for us, right? And so our geodesic equations are going to simplify to what? The first one is d by dt of what? Now E is just going to be F plus G, right? So that's going to be an F plus G. I'm going to suppress their indices, suppress the variables over here. Then that's going to be a U dot is equal to what? Is equal to 1/2 E sub u is F prime of u, and G sub u is going to be F prime of u. So I'm going to have a factor of F prime of u for both those things, F prime of u. And then what's left is going to be a U dot squared plus V dot squared, like so. And then the second equation is going to be what? It's going to be d by dt of F plus G, beautiful, V dot is equal to 1/2. And now these are V derivatives, so I have a prefactor of G prime of V in both of them. Okay, excellent. And I should mention these surfaces of Liouville are basically generalizations of surfaces of revolution, right? They have structurally the same form of those things. Okay, great. And so now what? And so now we also have one further assumption. We have our arc length parameter assumption, or our unit speed, because geodesics have unit speed, right? The unit speed assumption is F plus G u dot squared plus, that's my E, plus my F plus G v dot squared is equal to 1. Beautiful, right? Because now what that allows me to do is that allows me to write that u dot squared plus v dot squared, which occurs in both those geodesic equations, is exactly just 1 over F plus G, right? So now my geodesic equations can be rewritten are really what? Are really d by dt of F plus G u dot, that's this first term over here, is really what? Is really a 1/2 F prime over F plus G. F prime on top over 2F plus G, like so. Good. And then the second equation is what? The second equation is d by dt of F plus G v dot. I'm going to exploit symmetry here. It's just going to be 2, it's going to be G prime of V over F plus G. Okay? So let me take that first geodesic equation, rewrite it. So if I rewrite this first geodesic equation, what do we have? We have this equation over here. It's just d by dt. I'm going to multiply by this 2fg. So I have a 2f plus g. Then d by dt, so we can get rid of these guys. We can save ourselves some more space over here, right? So we're going to have 2f plus g. And then d by dt of f plus g u dot is equal to f prime of u. Okay? And so now if we expand out this dot over here, this is 2f plus g. Then I can have a what? Then I'll have an f prime. I'll have the derivative of this thing over here, so I'll have an f plus g dot u dot. And then a plus u double dot, and then f plus g. Okay, is equal to f prime of u. Okay, now what's important to realize, it's important to realize over here that this is really the differential. This would be beautiful if I had an extra u prime in here. If there was an extra, if there was a u prime over here and a u prime over here, then what would this be? This would be the derivative with respect to t of what? Of f plus g quantity squared, because that would be an f plus g quantity squared's derivative, and then times u dot, right? And then this would be a u dot squared, right? So that's beautiful. So what this is equal to, this implies that f prime of u is equal to 1 over u dot, because I don't have it there, then just d by dt of f plus g squared times u dot squared. Like that. Beautiful. And so now what that allows me to do is that allows me to put this u dot over here and then integrate both sides with respect to t, because that would be a t derivative now, right? So that would tell me that f minus c, that would be what I get when I integrate the f prime of u dot. So by putting u dot over here, right? So in other words, we can just bring this over here, and that's a perfect derivative. Is going to be what? Is going to be f plus g squared, and then u dot squared. And now since f plus g u dot squared plus f plus g v dot squared is equal to 1, I know that if I do the same thing with the v equation over here, so similarly, g plus c, because if I add these equations together, they exactly become the geodesic speed equation, is equal to what? Is equal to f plus g squared v dot squared, like so. Okay. Now if we take the square root of those equations, we can conclude the following. Taking the square roots, we can conclude that the square root of g plus c over f plus g is equal to v dot, maybe with a plus or minus, right? Plus, minus. And then u dot, and u dot is the same thing over here. It's going to be the square root of f minus c over f plus g. Like that, with a plus or minus. And now that's du dt, so what I can do now is I can say that these things are really, this v dot is really dv dt. This u dot is really du dt. So the conclusion now is that if I throw the dt over here and the dt over here, the f plus g dt is common to both those things. So our conclusion is that du over what? Du over root f minus c has to be equal to dv over the square root of g plus c. Okay? Just by separating the variables in those equations, and then we integrate and we're done, right? So the integral of these things, that tells what the plus or minus, of course, right? So in other words, the integral, so let's give ourselves some space over here, so let's just write down the conclusion. Okay? So what's our conclusion? So hence, the geodesics of surfaces of Liouville have the form that looks like this. So what's the form of those surfaces of Liouville? They look like this. They look like the integral of du over the square root of f of u minus c is equal to plus minus integral dv over the square root of what? Of gv plus c, and then plus another constant over here, c tilde over here. So in other words, these curves over here, this two-parameter family of curves, are the geodesics of surfaces of Liouville. Thank you very much.